All right, section 8.2 is on areas in the plane. So we talked a little bit about areas before. We haven't talked much about when a curve goes below the axis or anything, so we're going to be doing these types of things in this section. So suppose we have the sketch below, and we want to find the area between the curves f of x and g of x from A to B. So the way that you find it, you just, basically the area, like if I had this from A to B, that represents what I just shaded. So the area under your curve from x equals A to x equals B. So it'd be between the curve and the x-axis. All right, now if I wanted to talk about this area, this is a negative integral. So when we talk about area, it's a positive number. So if you computed from g of x dx, you would get a negative number out. So if we had like 10 and negative 8, what would the total area be for those two integrals? 18. So basically you'd have to make the other one positive and add them together. So what ends up happening is you just take the integral, just look down here, of f of x minus g of x, going from A to B. So that minus just represents that you're subtracting out that bottom part. You're making it the opposite. Okay, now the same thing happens. I mean, g of x doesn't have to be below the axis at all. If I had f of x here and I had g of x here, if I want to find the area between the two curves from A to B, think about how that would be. So if I just did the integral of f of x from A to B, that would be the green part plus that part below it, right? All the way to the axis. Okay, but if I want just the green part, I need to subtract out the integral from g of x. So basically the area between any two curves, doesn't matter where they are, so they could be above the axis or below the axis, is A equals the integral from A to B f of x minus g of x. So top curve minus the bottom curve. Okay, so number one, so it says find the area of the region bounded by y equals x squared plus 1. Hopefully you guys know what that looks like. So it looks like y equals x squared, it's just shifted up 1. Bounded below by y equals x. So y equals x goes through 1, 1, 2, 2, 3, 3. And bounded on the sides by x equals 0 and x equals, what did I cover up here? 1. So think about what this point would be. At 1, it would be 1, comma 2. And at 1, this one would be 1, comma 1. So this shape that we have has like a curve on the top and it's straight on the bottom. So it's like that. Okay, so we have a top curve, we have a bottom curve, and we're going from certain x values, from x equals 0 to x equals 1. So we just do 0 to 1. Top curve was x squared plus 1 minus the bottom curve is x. When you guys first start these out, I would put them in parentheses, just so you could see top part minus the bottom part, because it's not always just one term for that second curve, right? So you'd have to distribute the negative dx. Okay, integrate, so you get x cubed with a 1/3 out front plus x minus 1/2 x squared, going from 0 to 1. Plug in the 1, so 1/3 plus 1 minus 1/2. Plug in the 0, all of that's 0. 2/6 plus 6/6 minus 3/6. So 5/6, so 5/6 is the area. Does it make sense? Okay. Should be pretty easy for you guys. All right, so find the area bounded by the graphs of y equals 3 minus x. So again, think about what that curve looks like. 3 minus x has a y-intercept of 3. It has a slope of -1, so you're going to go down 1, right 1. So it's going to go through at 3, 0. And then x squared minus 9, do you guys know what that looks like? it goes through 0 and negative 9, right? That's its vertex, 0, negative 9. Where does it cross the x-axis? Negative 3 and 3, right? That's where y is equal to 0. So here and here. Okay, you can definitely see the top curve and the bottom curve here. So I know I'm going to integrate, and I'm going to have the top was 3 minus x, minus the bottom curve is x squared minus 9. But I don't know about my x values. I know that the second, my b value is 3. Do you guys see what I'm saying? So we're finding this whole area here. I want to find this one. So a equals, we don't know. So let's say this is a no calculator question. How can I find a? If it's a calculator question, it'd be easy. Just find the intersect, right? You graph both of them, find where they intersect. You get it immediately. Okay, if it's a non-calculator, what do you do? Yeah. Yeah, so it's just a system of equations, right? You have y equals 3 minus x, and you have y equals x squared minus 9. So Alex said he sets them equal to each other. In other words, y is equal to y, right? So you just take the 3 minus x and replace it for the y in the second one. So you get an equation with just x's. So I have x squared plus x minus 12 equals 0. So x minus 3 times x plus 4. So you get x equals 3, which is the one we already have, and x equals negative 4. So this is crossing at negative 4. Now if you had graph paper and you were super careful, you could probably guess, but we don't really guess in calculus. We like to see proof of why that is negative 4. All right, so this one we can simplify a little bit before we integrate. So negative 4 to 3. We have 3 minus a negative 9, so that's going to end up being 12. I have my negative x squared, and I have my minus x. So I just combine my like terms. So I get x cubed with a 1/3 minus 1/2 x squared negative, thank you, plus 12x, going from negative 4 to 3. I don't have my calculator, let me grab it. Okay, so you guys go ahead and plug in 3, plug in negative 4, see what you get. I got 45 over 2. So what you guys got? Minus, so plus negative 104 over 3. So minus a negative, so put plus. So what you guys got? So 57.167. Yep. Or as a fraction, 343 over 6. Yeah. So either way. All right, is this making sense? All right, so the next one. So find the area bounded by the graphs of y equals x squared. Notice you're going from 0 to 2, so it's always good to kind of mark in some points. That would be 2, 4. And 2 minus x squared. So 2 minus x squared is going to start at a height of 2, and then it's going to be a downwards parabola. So you're going to reflect it downwards. And then it crosses at plus or minus the square root of 2. Like if you wanted to solve for when it's equal to 0, you could do that. X squared equals 2, x equals plus or minus the square root of 2. So it's crossing at like 1.7, somewhere around there, and negative 1.7. Okay, so the shape that we get is this. Now based on my graph, it looks like maybe they're crossing at 1 and negative 1 for the x values. So we know we have a top curve, we know we have a bottom curve. So I have the top curve is 2 minus x squared. My bottom curve is x squared. Okay, but I need to find these green points here. Okay, so I need to find what those x's are. So I have my two equations. I have y equals and y equals, so I'm just going to replace the x squared for the second y. So I get x squared equals 2 minus x squared. Add the x squared over. You guys see it's x equals plus or minus 1. Okay. So this is the integral of 2 minus 2x squared dx from negative 1 to 1. So it's 2x minus x cubed with the 2/3 out front, going from negative 1 to 1. Okay. Now you can plug in 1, you can plug in negative 1. You can actually make this a little bit easier on yourself. So before I got to that point, actually, do you guys notice that this is symmetric? Do you know what I mean by symmetric? See how I could just do the right side? We always like integrating with 0. We don't like a and b to be hard numbers, right? We like it to be 0. So what I'm going to do is I'm going to say it's twice the integral from 0 to 1 of 2 minus 2x squared dx. See what I'm saying? Okay, so I get 2 on the outside, 2x. You could even pull out the other 2, right, if you wanted to. 2/3 x cubed, 0 to 1. So now it's easier because now that bottom one's 0. So it's all going to go away anyway. So I plug in 1. So I have 2 minus 2/3. So it's 4/3, 8/3. So you get 8/3 for your answer. Okay, so always make your life a little easier with symmetry if you can. Yeah, Alex. Oh man, 0 and 2. Ah. I wasn't even reading it. I was just saying the area bounded by the graphs. Okay, yeah, you're right. So I messed up. So let's say this one is from negative 1 to 1, and then let's do another one. So let me insert a new page. So you can do this other one in your extended notes, or your extra notes. Extended notes, what am I talking about? Okay, so we want the same graph. I didn't make mine wide enough. That's okay. Okay, so we're going from 0 to 2. Is that what it said? Originally 0 to 2. Okay, so this is a little bit different. So if I'm going from 0 to 2, I'm going to have this piece, and then all of a sudden I'm going to have this piece. It does. So Rachel says, does it change which one's on top and bottom? So what does that mean? Yeah, you have to find 2. So you're going to integrate from 0. We said this point was 1, remember? 1, 1. So we're going to integrate from 0 to 1 with our top being the 2 minus x squared. Or 2, was it? Yeah, 2 minus x squared. And our bottom was just x squared. And then we're going to add that to integrating from 1 to 2. And now our top is the x squared minus the bottom was 2 minus x squared. Does that make sense?
Oh, yeah.
You're adding the two areas.
How come the part write shaded and not the little triangle on the bottom. How do you know which one?
Oh, and this is shaded down here too. Is that what you're talking about?
No,
The
the
little
thing
bit not shaded
if
in
it's
between.
not shaded between that and that.
Because it's always sandwiched between those curves, and this part down here isn't between. Ugh, I don't know. Let me think. I understand what you're saying, but yeah. I don't know. I don't know the best way to describe it. Did she explain it?
Yeah.
Okay. All right. It's kind of hard to, yeah, it's kind of hard to put into words. All right, so this first one, so I'd have 2 minus 2x squared going from 0 to 1. The second one is from 1 to 2. It's going to be 2x squared minus 2. Okay. So 2x minus 2/3 x cubed going from 0 to 1, which we found earlier, right? Didn't we find that? So that was 4/3. Am I right? Okay, and then plus 2/3 x cubed minus 2x, going from 1 to 2. All right, so 8 16/3. That's a 3. Gosh darn it. Okay, so I'm plugging in the 2 first. So 2 cubed is 8, so I get 16/3 minus 2 times 2, so 4. And then minus, when I plug in 1, I have 2/3 minus 2. So I'm going to have 16/3 minus 4 plus 2/3 plus 2. So I get 4. So 4/3 plus 4. So you get 16/3. Alex, are you saying something?
You added the 2/3. So
Did I add the 2/3? Okay, 16/3 minus 4 minus 2/3. I added 2/3, so you're saying?
Yeah.
Okay, plus 2. All right, and then, so that's 2 and 2/3. So that's 8/3, so you're saying? So 8/3, so you get 4. All right, so your area is 4. All right, so let's try these ones. So same kind of thing. So find the area of the region bounded by the curves y equals sine of x and cosine of x between 0 and pi over 2. Okay, I went ahead and put these graphs in for you. Your book has a lot of the graphs in for you too, which is nice. Okay, so between sine and cosine. So which one, blue or red, is sine? Blue. I skipped one. Okay, we'll do this one first. All right, and we're going from 0 to pi over 2. So that's just this piece right here. Oh wait, is it? That'd be pi over 4, so pi over 2 is going to be somewhere around, what? Yes, somewhere over here.
It's right where it goes to 0.
Right where, oh yeah, that's right. It would be right where cosine is equal to 0, right? Okay, so right there. All right, so we need to find the point in between. So when is sine equal to cosine?
Root 2 over 2.
At pi over 4, right? Thinking of your unit circle. Your unit circle at pi over 4 would be square root of 2 over 2. It's common square root of 2 over 2. That's the when cosine and sine are the same value. All right, so we're going to go from 0 to pi over 4, and we're going to integrate the top, cosine of x, minus sine of x, dx. And then we're going to go from pi over 4 to pi over 2, and we're going to do that top, which was sine of x, minus cosine of x. Okay, so we integrate. So sine plus cosine going from 0 to pi over 4 plus negative cosine minus sine going from pi over 4 to pi over 2. Now, if this was on the non-calculator portion, you better hope you know your unit circle, right? So sine of pi over 4 is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. Sine of 0 is 0. Cosine of 0 is 1. So that's the first part. Plus cosine of pi over 2 is 0. Sine of pi over 2 is 1. So I have 0 minus 1 minus negative square root of 2 over 2 minus square root of 2 over 2. Okay, so this ends up being, when you do square root of 2 over 2 plus square root of 2 over 2, you get 2 of those square root of 2 over 2's. So it's square root of 2. So square root of 2 minus 1 plus a negative 1. And then I have minus a negative square root of 2, so plus square root of 2. So I think you end up with 2 square root of 2. So 2 square root of 2 is your answer. I think they canceled, didn't they? I think I wrote it wrong. So what did I say? Minus 1. Oh, maybe it is minus 1. So it's minus 2 at the end. I was canceling in my head, and they weren't canceling. Okay, so we get that. That's where sine and cosine have the same values on your unit circle.